Hey, welcome pre-algebra students. Here we go. We're going to dive into chapter 5 and try a little something different. I'm going to make a few videos here and there as a way that you can kind of take in your notes and examples at your own pace. You can pause this video as often as you need to or replay things, and it'll be kind of our way of diving into chapter 5. So, you definitely are going to want a calculator the whole time. We're going to do a lot of computation, and so make sure you have one handy. And I also want you to get your notes ready because we're going to jot down some examples and then I'll turn you loose on today's assignment. So here we go. Chapter 5, and this is Chapter 5, Section 1. So title your notes as 5-1 and then write ratios and proportions. Okay, and here we go. And again, if you need to pause it so you can get caught up with writing the examples and showing your work, that's totally fine. Okay, so this should be some review for you. You did this last year, but let's talk about what a ratio really is. Okay, a ratio, the way our math textbook explains it or defines it, is that it's a comparison of two quantities, it's usually numbers, by division. In other words, this is really just a fancy way of saying something that you can write as a fraction. Okay? Fraction. And the cool thing is that the word ratio is actually hidden inside the word fraction, which I think is just a totally cool kind of an English thing that ties into math here. All right? So basically, you just remember that a ratio is really a fraction. Now, the way they defined it, though, is it could be written as any type of division, and frankly, there are a few different ways that we can write a ratio. Okay, for example, sometimes you might see it written in words, and so we will use the word 2, T-O, 6 to 11. That's a ratio you're comparing two quantities. All right, that's one way. Another way you might see it written is using this notation with a colon, and we'll read it the same way, 6 to 11, the way we did it in words. Okay, and then last but not least, you can see it fraction way. And here is where you could read this as 6/11, 6 divided by 11, or 6 to 11 in words that way. All right, so you're going to see it in all these different formats, and you can always think of it mathematically as a fraction. Okay? All right, so let's think about M&Ms for a minute. And I'm going to tell you, let's say there's 32 M&Ms in the bag. You don't have to write this part down. We happen to have 7 red, 9 brown. Don't you always get more brown M&Ms in the bag, it seems? Yeah. 6 of them are orange, 3 are green, 5 are blue, 2 are yellow. All right. That all adds up, yes indeed, to 32. If you want to double check me, 7 and 9 is 16, 6 more is 22, 3 more is 25, 5 more is 30, 32. Yep, there we go. So if I ask you to write the following ratios of, say, blue to brown, then you just say, well, there were 5 blue and there were 9 brown. And you could write it as the fraction, or you could write it as 5 to 9 in words, or you could write it as 5 to 9 using that notation with a colon. Next one. What about blue to all of them? Oh, let's see. Blue, 5. All of them, the total was 32. So this time I could write 5 to 32 with words. I could write 5 to 32 as a colon. I could write 5 to 32 as a fraction. How about this one? There's only 2 yellows. There's 32 total, so I could write it as 2 to 32. You could write it with the colon, 2 to 32 this way. Or you could write it as a fraction, 2 to 32. Oh! I hope that your algebra or your math antenna is going off right now, because usually we do not leave a fraction that way. We usually don't leave any kind of fraction that doesn't appear in simplest form that way. So you could also say this is the same as 1 to 16 because the fraction, oops, make that a 16. The fraction 2/32 is the same as 1/16. So these are really both the same. How about that? Alrighty, the last one I had there is yellow to orange. And so if I look at that, and I'm saying yellow to orange, yellow to orange, yellow to orange. Let me get this link out of the way here for you. I'll slide that guy down. All right, yellow again, I had 2 yellows and there were 6 orange. So you could write it as 2 to 6 this way, 2 to 6 with the colon, or 2 to 6 as a fraction, and then you might say, it's not in simplest form. So I better write it as 1/3, or 1 to 3, or 1 to 3 this way. Okay? If you write it in words like this or like this, I'm not going to mark it as incorrect. I just want you to now get back into your fraction mode and think about simplest form. All right, so that's what a ratio is. Then we need to talk about proportions. Write this word down, proportion. A proportion is simply an equation, okay? It's an equation. So that means, hey, I have to have an equal sign in here. And it happens to be an equation where you have 2 fractions, or I guess I suppose I should use the word ratios, but really we're almost always going to write them as fractions. 2 fractions that are the same, or in other words, they have the same value. Okay? Sometimes you'll see we use the word equivalent to represent that, or I might just simply use the word they're equal. They're equal to each other. Okay? Now, what does that mean? Well, here's something that you'll probably have to do in your assignment today. It says, the directions say find 2 ratios that are equivalent to this ratio. So here's 9/27. Nice little fraction. Can you give me 2 more that are equal to that? Well, gosh, if I'm thinking in my good old simplify this, I'm thinking both of these have a 3 as a factor, and if I divide a 3 out of each of these, I could say 3/9 works. There's a ratio that's equivalent. I could keep going and I could divide by 3 again, and actually in simplest form I also get 1/3. Cool! Very cool. Do another one quick with me. 64/24. Wow. Well, gosh, there's a lot of things I could do with that one. They're both even, so I could think 64/24 if I factor a 2 out of the numerator and denominator, I could get 32/12. That would be equivalent to it. And if I kept going, divide by another 2, I'd get 16/6. There's another one. And actually, oh my goodness, you know what? There are an infinite number of correct answers here. You know, I could keep going till I get in simplest form. Here's another one, 8/3. Or I could even multiply both of these by something. You know, I could take 64/24 and multiply it by 2/2, and I'd get 128/48. That's also similar. All of those are equivalent to each other. Okay? Cool. Now, why do we do that? Well, I'm getting after this, using this proportion idea to start looking at a pair of ratios and tell me if they really are equal. In other words, would they form a proportion? Now we're kind of getting into showing you what a proportion looks like. Now, if I had you take this and make each of these a fraction in simplest form, you'd say, well, 3/27, if I took 3/27 and divided by 3, took a factor out of the numerator and a factor, out of the denominator, I'd get 1/9. So 3/27 is really the same as 1/9. And guess what? 2/18. If I simplified this one, divide by 2, that's also 1/9. Yes, indeed they are equal. These directions said simplify, put them in simplest form to do that. And there's how you could show that. So this one you would say yes, because 1/9 equals 1/9. These guys, 12/15 and 27/36. Ugh. Let me see. 12/15. Let's see, there's a common factor of 3 here. So if I divide by 3 on top, I get 4. I divide by 3 on top, I get 5. What happens over here in simplest form if I divide by 27/36? Hey, it looks like there's a 9 in common. I know some of you prefer writing it this way, so let me write it this way if this is more comfortable for you than the way that I simplify here. Dividing a factor of 9 out of the numerator and the denominator would give me 3/4. Uh-oh, 3/4 and 4/5? No. These do not form a proportion because they are not equal. Okay? They are not. Now, another way that you can do this, and we haven't talked about this as much yet. Let me throw a clean screen in here for a second. There's another way to test if fractions are equal to each other. So let's make up a couple fractions that are the same. I'm going to pick the most common fraction, or the most famous fraction there, 1/2. And let's see, a fraction that's equal to that one, oh, let's say 4/8. I know these are equal. These form a proportion, yes, because I know that 4/8 in simplest form is 1/2. Or I could turn these both into decimals and prove that they're both 0.5, and yes, sirree, they're equal. But here is another interesting property about proportions that's always true. If I have two fractions that are equal, there's something about what we call the cross products. And these cross products, I'm going to write this down. These cross products mean take the numerator of the fraction on the left and the denominator on the fraction on the right and multiply them, those two values. 1 times 8 is 8. Do the same thing with these cross products. So I'm taking the denominator on the left and the numerator on the right. That also gives me 8. The cross products are always equal in a proportion. Cool. And you can use this property to test and see if you in fact have a proportion. So here's an example from earth science that says at 4 degrees Celsius, 4 cubic feet of silver has the same mass as 42 cubic feet of water. So that's why they have the 4 here. This is the silver on top, or I'm sorry, this is the temperature, the degrees, and then this is the silver. Then they're saying at 4 degrees would 210 cubic feet of water, 4 cubic feet of silver. Sorry, I've got this messed up. Let me go back here a second. 4 cubic feet of silver. This is the silver. See, I was messed up because this temperature is also 4, but it turns out I'm not going to need that. Silver and water. Okay? And so they're saying, is this 210 cubic feet of water the same? Would it have the same mass as 20 cubic feet of silver? So we're basically asking, is 4 over 42, is it really equal to 20 over 210? Grab your calculator and let's check. I'm asking you if 4 times 210, this cross product, is this really equal to 42 times 20? Oh, I don't need a calculator for this. Good grief. 840 here. And when I multiply this one, well, look at this. 840. These are equal. So this one, you're going to say yes, because the cross products are equal. Therefore, it is a proportion. That's a way you can check. Okay? All right, what I'm going to do now is kind of stop right here, and I want to get you going into your assignment for today. Okay? It's going to be in the textbook. So grab the textbook that's underneath your desk, open up to pages 218, 219, and I want you to do these problems 11 through 47. Now, before you start whining a bunch, it sounds like a lot, but these go very, very quickly. I'm not worried that you can handle this and get this done so you don't have a lot of work outside of class. All right? Good luck, and make sure that you're accurate with all of your fractions and checking your proportions.